pick a problem. Maddie, pick one of the ones that's giving you trouble. Just call it out to me so I don't have to look it up.
Pick it. Why is that thing? Just go. Just pick problems.
Page 323, number 8.
Number 8 on page 323. Everybody turn to that page. Call it out to me, Maddie.
9k cubed.
9k cubed.
M squared. N.
Wait, 9k cubed m squared.
N or M?
M.
Which one? Right? Yeah, M. It has M in it.
Oh, goodness, yeah. M squared n. M squared n.
Plus 3k squared.
Plus 3 what?
K squared.
K squared.
M n squared.
M n squared like that?
Yeah.
Go ahead.
Plus 54 k m cubed.
K m cubed.
N.
N.
Over 6k m n.
Over 6. Oh, this is one of those. K m n.
Yeah.
This is by monomial.
Hey, what's your name?
Oh, yeah. I should know if you needed me. Remember, when we divide by a monomial, one term, we put each one over 6k m n. 6k m n. So this is not long division, is it? This is not long division. Let's move this plus sign here. This plus sign here. It's like 3 different terms now. And then we just cancel. Okay? 9 and 6, let me get a different color. 9 and 6 can both be divided by 3, can't they, Maddie? So 9 divided by 3 is 3, 6 divided by 3 is 2. So my answer is going to have a 3 here and a 2 here, right? Now, I have k cubed here and k to the 1 here. 3 minus 1 is 2. My answer always goes in my numerator. If my exponent is negative, then I move it to the other side of the fraction line, right? Now, this is m squared. This is m to the 1. If there's no exponent there, it's to the power of 1. So the m's match. So 2 minus 1 is 1. I put it in the numerator. It's positive, so it stays in the numerator. And now, 1 minus 1 is 0. That gives me n to the 0. N to the 0, anything to the 0 power equals 1. So this is 1, right? Well, 1 times 3 is just 3. So I don't put that. I'm done. If it's n to the 0, I just don't put it unless there's nothing else in the numerator. Then I leave the 1 there. Now, 3 and 6 can both be divided by 3. So I'm going to put a 1 here and a 2 here. These are both positive, so I'm going to put a plus sign there, right? 2 minus 1. So finish that up now. Sit. Sit. Everyone sit. Miss Alexis? No. Plus it down and call me if they don't listen, okay? You have to be sitting. Noah, don't look at me and laugh. I'll smile. I'm glad you're happy, but are you doing your flashcards, Joe? Do I need to take your phone, or are you going to put that phone in your backpack and leave it there? You've been playing. It's time to study. You haven't studied since the last time I was in here. Will, what are you working on next? Study your flashcards. Study your flashcards until you know them. Bo, you're working on your math finder. And then if you have time, I want you to study your flashcards. Noah, you know what you're doing? Don't let me hear this noise again when I come in here. I'm leaving this door open now. No getting out of your seats. Of course, always for that. On Thursday, Will and Joe, I'm going to give you a quiz on that science. On Thursday, I'm going to give you a quiz on that science. So you have to study it until you know it. Write yourself up, make your own quiz, Joe. That's a good idea. Both of you make your own quiz. Don't get pencil or ink pen on my table now. Huh? Instead of studying your flashcards, if you think you know, then make your own quiz. Will, do you think you know your flashcards? Okay, do you have them in front of you? Okay, so study them now. You have to flip them and study them. That's a good idea. Quiz each other quietly, very quietly. Sorry, y'all, Julia has to leave for a doctor's appointment. So, okay, so K's match 2 minus 1 is 1, but I don't need that 1, do I? If it's a 1. M, 1 minus 1, 0. So end of the 0 is just 1. Now 2 minus 1 is 1. So now I don't need this 1, do I? Now, 54 and 6 can both be divided by 6. That's 9 and 1, right? So they're both positive. I'm going to put a plus sign. I have a 9 here and I have a 1 here. 1 minus 1 is 0. 3 minus 1 is 2. And 1 minus 1 is 0. I can leave this over 1, or I can just change this to plus 9m squared. Does that make sense? Mm-hmm. So when you're dividing by a monomial, you divide each term by that monomial, right? Mm-hmm. Okay? That's different than when you're dividing by a binomial, 2 terms. Huh? Any questions about that, Maddie?
I have a question.
Oh, go ahead.
How do you come up with the numbers? You just know that.
What numbers?
This was how you came up with the numbers.
This is the problem.
Right.
And this is the problem. So how did I come up with this number?
How do you come up with that number?
Well, it's a 9 and 6. I reduced this. I reduced this fraction by dividing top and bottom by the same number. 9 divided by 3 is 3, and 6 divided by 3 is 2.
Okay.
Does that make sense?
Mm-hmm.
Very good, very good. So you can reduce. It's just like a fraction. If you had 9/6, what would it be?
Right.
It would be 3/2,
Right.
wouldn't it? Same thing.
All right.
But now remember, we divide because this is division. But when we divide exponents, we subtract.
Right.
Right? We subtract. It's just a shortcut for dividing exponents.
I get it now. Okay.
Any questions about that? Did that answer the problem you were having, Miss Fanny? Okay, very good. So now,
I'm glad she asked that because I didn't realize I did that wrong.
Very good. Any other questions? Anybody have any other questions? Miss Fanny, do you have any other questions?
Can we just go over one of the division ones?
Mm-hmm. Yeah. Call it out.
I don't have a second.
Which page though? Would you want it?
I mean,
The long division ones? Or?
yeah. I don't
Uh,
have a specific one. I was just wondering.
2n squared.
Do one that has a cube at least.
2n cubed
2n cubed
plus 20n squared
plus 20n squared
plus n
plus n
divided by 10n squared.
divided by 10n squared. Well, that's a monomial. That's the same thing.
Oh, okay.
We need one that's dividing. That's just the same thing that we just did, huh?
Right.
Right? We're just going to cancel. But we're looking for one that's divided by a binomial.
Is that like, which one is that like?
N minus 2, 3n minus 3x minus 3.
Oh, okay.
That's a binomial. Look right here. If there's no plus or minus sign in it, so that's just one term.
Okay.
Because there's no plus or minus sign in it. This is a monomial. One term. Monomial.
Here's a tricky one.
A binomial. minus or plus. See, this is a binomial
Okay.
separated by a plus or minus sign, two terms. Yes.
I have a really tricky one.
Go ahead.
Negative 18a
Negative 18a
plus 3a cubed
plus 3a cubed
plus 9
plus 9
plus 6a squared
plus 6a squared
divided by negative 3 plus 3a.
plus 3a. Okay, so now the first thing we have to do is put everything in descending order. The greatest exponent comes first. Positive 3a cubed. Positive 6a squared. Negative 18a. And positive 9. Divided by a positive 3a and a negative 3. Does everybody understand that so far? Okay. Now, I'm going to do long division. 3a cubed. I have a cubed, a squared, a 1 power, and a constant. So I don't have to fill in any zeros, right? 3a cubed plus 6a squared minus 18a plus 9. Now, remember, 3a minus 3, divide each one by 3. This is a minus 1, right? Oh wait, I'm sorry. That's for synthetic division. Oh, it's just 3a minus 3 divided by 3a minus 3. We'll do it synthetically too. Now, I ask myself, how many 3's are in 3a cubed? How many 3a's are in 3a cubed? 3a times what equals 3a cubed?
A squared.
A squared.
Aren't you supposed to put it over this 6?
Yes, thank you. Hello, the square. Thank you. You see that, Maddie? We always say 3a times what equals 3a cubed? 3a times a squared. So we have a squared. Now we're going to multiply. A squared times 3a is going to be 3a cubed. That always has to be, right? Or we didn't do it right. Yeah, but anyway, don't worry about it. And then we do a squared times negative 3 is negative 3a squared. We have to remember that we have to subtract the whole thing. We have to subtract the whole thing. 6a squared minus negative 3a squared is plus 3a squared. So we make that a plus. Minus and a plus. 3a cubed minus 3a cubed, of course. 6a squared plus 3a squared is 9a squared. We bring down negative 18a. What do we ask ourselves next, Miss Maddie?
How many times can...
Does 3a go into 9a squared, right? Mr. Bow, I want you to get away from the other two, okay? Go on the other team. So Maddie, we want to know how many 3a's are in 9a squared, but an easier way is to say 3a times what equals 9a squared, huh? You see that? 3a times what equals 9a squared, Maddie? 3a. So we're going to put, that's a positive 3a, so we're going to put positive 3a there, right? Then we multiply 3a times 3a, 9a squared, 3a times negative 3, negative 9a. We have to remember that we have to subtract this whole thing, which means do that. Of course, 9a squared minus 9a squared is 0. Negative 18a plus 9a is negative 9a. We bring down the plus 9, and we start over again. Try starting over again now. Do that last step for me. So I have no remainder. Now, this is important for what you're going to do next year with this.
Which is
If this divided by this equals a squared plus 3a minus 3, right? This right here divided by this equals this answer because there's no remainder, right? Okay, so I'm going to erase this now so I'll have some room underneath it. Now, if you have some number 6 divided by, let's say 2, that equals 3, doesn't it?
Mm-hmm.
And you know, fact family tells you 3 times 2 equals 6, right?
Mhm.
So this times this equals this. So if you look at 3a cubed plus 6a squared minus 18a plus 9, if you have 6, you divide it to 2 times 3, don't you?
Mm-hmm.
That's a factor tree. Now these are both prime. These aren't necessarily prime.
That's where that ends. You can't.
But this divides into 3a minus 3 and a squared plus 3a minus 3. This times this equals this, just like this times this equals this.
Mm-hmm.
You see that? This is where you start getting to solve. So let's see if this is factorable. No, this is not. We would have to use quadratic formula for that. But let's suppose that this isn't, but let's just suppose this is not true, but let's suppose it were plus 4. Okay, let's just suppose whatever it is, well, we can find out what would this be. This, if we multiply this times this, we would have, let me do it over here, 3a times a squared would be 3a cubed. 3a times positive 3a would be positive 9a squared. 3a times positive 4 would be positive 12a. Then negative 3 times a squared would be negative 3a squared. Negative 3 times 3a would be negative 9a. And then negative 3 times 4 would be negative 12. Is everybody following me?
Mm-hmm.
So this times this equals this, doesn't it?
Mm-hmm.
So if I had this, it's not this one, I want to show you something else. 3a cubed plus 6a squared plus 3a minus 12 equals this times this, right?
Mm-hmm.
Now, this we can factor a 3 out of, can't we? So this can be broken down to 3 and a minus 1. Does that make sense?
Yeah.
So these are now prime because this can't be broken down anymore and this can't be broken down anymore. There's nothing times something else that will equal a minus 1. But 3 times a minus 1 equals 3a minus 3, doesn't it? Right? Now, how can we break this down? We can factor it, right? Okay, so here's our diamond method. We have 4 here and 3 here. Let's make this darn. I calculated it backwards. Let's just pretend like it's negative 4. This is not exactly right, but let's pretend like it's negative 4. So we're going to do negative 1 times 4 equals negative 4, and negative 1 plus 4 equals 3. So then if it were this, this would factor to a minus 1, a plus 4. Does that make sense?
Mm-hmm.
Okay, so now, suppose I had, what is this going to be? Let's just suppose that that equals that, so I don't have to go back and do it. So if we had 3a cubed plus 6a squared plus 3a minus 12 equals 0, we would know, pretend, that this breaks down to 3 times a minus 1 times a minus 1 times a plus 4 equals 0, right? So look, you're looking up here?
Yes, ma'am.
Now, how can I solve for a? Well, 3 is never going to equal 0. But if any one of these is 0, it makes it true, right? So either a minus 1 equals 0, or a minus 1 equals 0, or a plus 4 equals 0. Add 1 to both sides, a equals 1. Subtract 4 from both sides, a equals negative 4. This one has two solutions. If I hadn't messed this up, right? So there are two solutions to this equation. There should be three, but you see this one is double. Okay, and so there are three solutions, but one of them is a duplicate. Because when you see that, and so that's why part of why we're learning to divide. It's very important for your next math or college. This is more pre-calculus than trig, and we're doing a lot of trig really, and but you need to know this eventually, is my point. And this is why, so I'm just showing you, you don't have to know how to do this, but this is why you have to learn division now, because you are going to be using it later on. Does that make sense?
Yeah.
Okay. So now, this was our original equation, right? And our original answer, right? So now, let's do it synthetically.
Which I did wrong somehow, I don't know why.
Say it again.
Which I apparently did wrong, and I have no idea why, but figure it out.
Bring these down. Right? Now, 3a minus 3 is a minus 1, right? 3 times a minus 1. A minus what?
1.
1.
Oh, that's why I did it wrong. I ended up doing -1.
A minus what? That's the
1.
question you ask
1.
yourself.
Yeah,
You ask yourself, x minus what?
That
Well,
does confuse me.
If it was plus, you make it minus.
Minus negative.
That's when you're at negative.
Right, because if you had a plus 1, it would be a minus -1. A minus what? -1. So you ask yourself, a minus what? X minus
that
what?
explains why mine was completely off. Okay.
Very good, very good.
I was concerned.
We bring our first one down. 1 times 3 is 3. 6 plus 3 is 9. 1 times 9 is 9. Negative 18 plus 9 is negative 9. 1 times negative 9 is negative 9. We have a 0 there. Now remember, it starts with a cube.
Wait, Lori, that's not the thing.
Hold on, you'll see.
Okay.
Remember? Hold on. So, remember we started with a cube, so we do a squared, a, that's a positive, constant with no remainder. So our equation is 3a squared plus 9a minus 9, but remember, we have to go back and divide by 3, don't we? Mm-hmm. We have to divide because we took that 3 out. We have to go back and divide by 3. A squared plus 9 divided by 3 is 3. 9 divided by 3 is 3. A squared plus 3a minus 3. A squared plus 3a minus 3.
You have to reduce it before you can divide.
You have to reduce this so that it is only a right here. This 1 is only when there's the coefficient of this is 1.
Right, the equation is negative 18a plus 3a squared plus 9 plus 6a squared.
That's what this is, and we converted it to this by putting it in order, right?
Okay, never mind. That's what I missed. That's why I was confused.
You
Okay.
have to put it in order first. Yes. It
It
has to be in descending order. And that's okay. Let's work through it, make sure.
Yeah.
Let's do one more like that. I'm going to look one up
That's
online
that's
that we
what
haven't
confused
done.
me there. Okay.
Say it again.
That's what confused me there. It threw me off completely.
Let me look up a practice one online. Huh? Oh, thank you.
Yeah, I'm telling you. It's right. I know, but the thing goes down over there. The color you saw your best friend. The color of the so I just don't. I don't know. Second, y'all sit right next to each other.
Come on, load.
Maybe. Nah. I'll sit on the floor. Weird.
Okay, so let's do this one. Take out some paper. We have 2x cubed plus 7x squared plus 2x plus 9 divided by 2x plus 3. We're first going to do long division. And then we're going to do synthetic division. Then we're going to compare the two. And if you got the same answer, then you know that both you did it correctly both ways.
I'm gonna be honest, I'm not trouble with synthetic. Why do you have trouble with synthetic? I'm trying to long. Look at the binomial. You divide it. You divide both. You have a fraction. Oh. Yeah, that's what I'm saying. I don't know how to do that. Exactly. Oh, what are you having trouble with synthetic? Alright, but you can synthetic is easier. When it's normal. Yeah, it is. Okay, normal is not in the vocabulary. I'm talking about a normal problem, like compared to other problems. No, I'm saying. Oh, you did. You did. Oh, yeah.
Yeah, because we skipped a few. Okay, quiet now. Quiet. Quiet. Turn around, Joe. Joe, do I need to bring you in here to sit by me? If I catch you talking or not studying one more time, I'm going to bring you in here by me. If y'all did not pass this science test on Thursday, I'm going to talk to your parents about leaving you after 3 so I can work with you one-on-one to get you to pass it, okay?
I get 2x cubed. X squared times 2x. X, that's not x cubed. That's a 2 though. Yeah, you don't multiply this by this. Yeah, you multiply this times this. Screw this. That's not part of it. This is the same problem. This right here is the problem. This is just me copying it down. Right, it's 2x. I put 2x as the answer, so I multiply this. I told myself to remember that. I told myself not to cry. Oh, yeah. You were asking me like an hour ago.
Shut
I
up.
don't do this.
Well, let me know, a lot of paper towels.
Yeah. I haven't used that bathroom in a year.
Hasn't been here for a year.
I don't care. I still haven't used it.
Did you see my new paper towel holder in here?
What?
Did you see my new paper towel holder in here?
No, I'll go to the bathroom.
You should check out my new paper towel holder. I'm very
It's
proud of
good.
my new paper towel holder. I feel professional with a paper towel holder.
If that's what you're relying on, professionalism.
I just dropped them all over the floor.
Need some help?
Oh, no, I'm good, thank you.
Wasn't gonna.
Need some help for professionalism.
Is that 2x? 2x for Second.
Just wasted a whole lot of paper towels, though.
Drop them.
Yeah, drop that back on the floor.
This is 2x.
I'm looking at it. I'm thinking right now.
This is 2x.
To be 100% honest.
2x. What's 2? 2x times 2x? 2x. 4x squared.
Yeah, but that's not what I look. Oh wait, yeah, it is 2x. I'm tripping. I'm trying. Okay.
Did you want us to do synthetic too?
Uh-huh. Make sure you get the same answer.
That's easy. But actually, we're gonna have a
Yeah.
problem with synthetic just because you would have to get rid of the 2.
Uh-huh.
And in order to do that, you have to divide. And 3 isn't divisible by 2.
Let's do that, you're right.
So I'm okay with
It would
this
be-
one, but synthetic.
Did y'all get this answer?
I didn't finish.
What is it, 3 over 2x?
What's the answer? What did you have?
Yep. Oh, wait.
I didn't write it into that yet.
But yeah.
Gotta remember that's how you write it.
3 to 4.
Use your calculator for each one of them, Lucas.
That's just like parentheses, -3 divided by 2, right? That's how you type it. And then use the minus.
And then get your answer in fraction form.
But yeah.
Do you know how to do that on your calculator?
I do, yes.
How are you supposed to do it if you don't know how to do it?
I'm getting ready to show you.
I got -3 for the first one. Does that make sense?
That's correct. Because 2 times -3 halves, the 2's cancel. Where's your calculator? Keep it right there by you.
put it over. That's my thing is not even like fractions. That's what it is.
You don't need that for this one, but next one is zero. Here's divided by.
Oh, it gives it to you. You already have it in fraction form. Oh, it does that. So, you're gonna do, what does that say? -3.
Equals bottom. Yeah, see.
That's the answer for that one.
But how do I get to the thing? Like, look, see, this is all the stuff I have. I don't know what it does. Equation? Is that what you mean?
We're done.
Oh, it's the right.
So do that.
Oh, okay.
Killed it. I thought you killed it.
I killed you.
Oh, it's
It's a
That's the
zombie
same
fly.
That's the same fly. Look how big it is. This thing. Don't worry about it. Finish it.
That one was snatched on my book.
It's not there no more.
Wait, that's right. Oh, wait, where did it go?
It would give you a fraction if you had it, wouldn't it?
Oh, the zombie fly.
Oh, is this fraction decimal? Actually, is this fraction decimal? This one.
Was that a -6, Maddie?
This one.
Yeah. You figured out how to do it? You showed her how to get the fraction?
The Casios.
Oh,
We've had this conversation a good 80 times. It's nearly impossible.
where's your clear button? That's your name. I think I should maybe go use my calculator. Say that again?
I'm trying to figure out, I don't know. Oh, that's one, never mind.
This is a
Oh,
cube,
yeah.
so we
That's
start
fine.
with x squared.
I'm trying to find my error.
But remember now, I have to
Alert.
divide each one of these by 2, don't I? Right? Miss Maddie, remember that? I have to divide each one of these by 2 now, right? Same answer.
But how do you know which X is to add on if you don't didn't do long division first?
If it starts with cubed, this one is squared.
Oh, okay.
Always one down, because remember, you have an x here, so it's always going to be x squared to be your first term.
You talking about doing this one?
Okay, yeah.
Yeah, there these are different.
What's that? Divide all of them by 2.
Alex knows how to do this.
Yeah, that makes sense.
stat wizard to
What's that?
Okay. Any questions?
Nope.
Are we ready for our quiz? I'll tell you what, we're gonna have the quiz next week since I just showed you.
I can't take it right now. I'm more prepared
No,
than
because I
will be.
know that you can, but will you hold on to it? Will you know
Right.
it again next week? I know you know it because I just showed it to you, right? But I need for
I
you
kind of
to
feel like
be
I
able
want to do
to,
another one to confirm that I know it.
huh?
I kind of feel like I want to do another one. To
You're gonna
confirm.
do another one on your own, aren't you?
Yeah.
Yeah, with your homework. Redo your homework if you need to,
And what are we going over?
huh?
And what are we going over?
I'm getting ready. What do we have next?
Next what?
What?
You
No,
give
I'm-
us-
We
Concepts?
don't have any more.
We don't have
papers.
anything else.
My phone died. We'll take a short break.
Okay.
Good fortune down.
For a bad battery.
Phone dead. Okay. Until your phone comes back.
Oh, I have an iPad. Don't worry. I've got a backup.
We never figured out what these were
Come and show them to me, if you wouldn't mind.
for. I'm the only one that has it.
Say it again.
I'm pretty sure I'm the only one that has it. It was in my folder.
This is when we were doing parabolas and evaluating the functions.
I just didn't have any page numbers.
Yeah, check with Lucas. Lucas should have the right page numbers.
You would know.
You need to remind myself to put more papers in this binder.
I've never even seen this page before.
This is ranging. Yeah, I know what it is.
You can tell her what,
It's ranging.
I did this?
I doubt it.
Did we do it?
If you're asking me. I'm pretty sure that's it right there, right? Nope. Getting close. Boom.
It goes out to this.
I don't have it numbered.
It goes out to this page. 242.
Yeah, so just, that's 244. So just name it numbered. I don't have them numbered either. I don't think it's extremely vital that you have them.
Does it skip straight from there to there? Yeah, it does. Oh, never mind. You can't number it. Because this is 243 and this one's 242.
Just put it in between there, that's where it belongs.
So if you number it, you
Which one's 242?
at the end of that. No, it's all the way there. The next page in your packet.
This is 240.
Oh, never mind.
Which
He's
one?
missing from 243 to 260.
I just didn't know.
Oh, that's what you're missing.
I ain't number none of mine.
I do it if you want. There's no point.
I know why you're missing it.
I'm ready to go.
It's been an hour.
I'm still ready to go.
I was ready to go the second I walked in the door.
Really? I'm really tempted just to wipe my phone to try to make it faster, but
yeah.
it's like ridiculously slow.
It's slow because you have a bad battery.
Probably why, yeah.
Every 6 months they make the phone slower to keep up with the battery.
Right. Can't get a new one for a few more weeks though.
You can get a new battery.
Could get a new battery, yeah.
It only costs $30.
Then I have to go get a new battery.
Order one.
I would suggest ordering it.
Yeah.
I
That way
don't
you
know
don't
where
gotta
you
go.
go buy an Apple battery.
Apple store.
I
Really?
think they sell
You
batteries.
can't,
Yeah, they can replace
Yeah,
batteries
you
there.
can't-
Bring your battery there.
you're not supposed to do it yourself because you could easily break the phone. Cause
They do too though.
I do.
They make it really hard to do it. They do it at Apple, yeah, but
They break phones a lot too, but they replace them. Apple breaks the screen a lot because the screen's very
right.
Break
I'm
mine.
kind of hoping they do break the phone if they do that then.
They don't replace your phone, they just replace the screen. Because that's the only part they can break.
Yeah,
Who's absent?
I don't know.
The whole world.
Logan, he's done this. So.
He was. He was.
He was coming here.
I don't know who's last like 3 weeks we've had just us. I think.
Yeah, I know.
Yeah.
No one else has come.
It's just, hasn't it just been 3 of us for the past couple weeks?
Three.
What?
3.
3. Unless,
1,
no, I
2,
think
3,
he's been
4.
Here
Yeah.
too. Never mind.
1 plus 1 plus 1.
There
Sorry.
you go. What's the verdict? 4. Judge rules.
I got good at the count.
I was expecting to do this while y'all were taking the quiz. So,
Yeah, and then the quiz didn't happen.
Bro, that's not me. I guess I had to go to the bathroom.
And then I come back and I'm in the bus.
Yeah, I had to get something to drink real quick, and then by the time I got back, I was already at the end of the map, so I just jumped.
Were you playing solo or squad?
Squad.
Yeah, I
my
know.
whole squad.
I'm like, oh my god.
Throughout the whole game, we was just setting a point to meet at, but we never got there because we all died before then.
Wow.
But I hate it when people leave me. I leave you all the time, but I hate it. You're slow.
I always get the best loot, so it's good. Bro, what is that? A waffle pancake? Bro, that looks amazing.
I know. A pancake.
I'm not eating that anymore.
We'll work on the name. It's a
I'm
good
not eating
product.
that.
Wait, what would you call it?
Oh, that's not mine.
Waffle. Waffle.
What do you think about? Get you some waffle.
I was at my friend's house playing Fortnite. He had one of his sister's girlfriend. His sister's boyfriend was there. And we were playing Fortnite. I was getting hella lucky. I got a scar every single round. Is it? Yeah.
Look at this lid.
2, right?
Yeah.
Let's see. I want to see that movie, Rampage. Is that the name?
Yeah, with
I used to play the Wii game when I was like 6, or not 6, like 8.
Yeah, so like a monkey with your.
What?
There's like an albino ape.
Not the game. In the game, it was a big, it was like all the giant, like, it was like a Super Smash Bros.
Ah, that's fun. There's a Godzilla.
But you could climb on the side of the building. And if someone knocked you off, you had to try to land, and you'd go over top and whoop the hell out of each other. It was lit. Still remember the wolf's name, because that was my favorite character in that game. It was Ralph. Something like that. I think it was Ralph.
Okay, yeah, you apparently have a very keen memory of that game.
Ralph. Pretty sure it was Ralph. I think it's that in the movie, too. Now they just name wolves in the movie, but they didn't know what.
Like no prologue before it. Yeah, this guy really doesn't think good.
That is.
That's not him.
That looks.
That's not him.
That looks like his twin brother. All his siblings, Chris.
Yeah, they all look alike.
Exactly like when they get older.
You know
They all
Kevin Hart?
Yeah.
Yeah, his mom looks exactly like him.
I ain't never seen Kevin Hart's mom. So I don't know
It was in
his
a
mom.
family picture when they're like,
His son looks like him.
yeah.
Hell of a.
I wonder if he's gonna be funny. Yeah.
They're gonna make They wanted to make a movie, like about because Kevin Hart took a picture with Dave Chappelle,
Yeah.
the big comedians, and said we should make a movie about a road trip.
Right, that's been done so many times.
Between them though, yeah, I was the
I'll
biggest
watch
comedians ever. What's the one that played on all the Dr. Doolittle ones? food. So then Eddie Murphy, he was the only one worth in the picture, but people were commenting on it plus Eddie Murphy. Just don't go nowhere. I want to keep him in the car.
My friend thinks you're cute. Cosine in the corner. He's in the car, just looking through the window. We leave him in the car.
It's the best that way.
Tends to not go anywhere.
You think kill anyone?
I say go.
Oh, let's not a killer. You know what ain't depressing one?
Fortnite.
There's one thing that is not depressing.
What that even?
I don't know what it is.
Okay, take out some paper, we're gonna take some notes.
Scary.
Yeah, I thought we were gonna
Take a quiz.
So I'm gonna give y'all that quiz next week, so I want y'all to be prepared for it, okay?
I'll take that later.
Oh, triangle.
Pythagoras.
Not Pythagoras.
Yeah,
Trig
Lucas.
ratios. Trig ratios. When I have a right triangle, I have a right angle, and then I have two acute angles, right? Two angles that are less than 90 degrees. Because this one's 90, so together these two are 90, aren't they? Right? So, let's say that this one is 40 and this one is 50. Okay, let's say that this one is 40 and this one is, well, no, let's say, hold on. Let's say
That's
this one is
impossible with a 90-degree angle.
40 and 50
Oh,
and
wait,
90.
never mind. Yeah, sorry. I was thinking 60 out.
Let's say 30 and 60. There's my got our answer. That's my problem. That's right. Let me get a calculator here. So, you have to choose what angle you're standing at, okay? You have to choose what angle you're standing at. If you're talking about a 60-degree angle in a right triangle, you're standing at the 60-degree angle. From this perspective, this side is opposite of you, isn't it? It's opposite of where you're standing. You see, if you're standing here, this is the opposite side of you, right? This side is adjacent to you. It's next to you. The slanted side, which isn't always obvious, but across from the right angle, this is like a little arrow here, across from the right angle is the hypotenuse. Now we have what we call trig ratios, trigonometric ratios, sine, cosine, and tangent.
I remember this.
This is how they're spelled. This is how they're abbreviated. Now, when you have a right angle triangle, let's just look at this 60-degree angle. When this angle is 60 degrees, this side is a very particular size, isn't it? look, as I increase this angle from 60 to 65, now this side has to get longer, doesn't it? The larger this angle gets, the longer this side is. So the sides of a triangle are related to the size of the angle in a right triangle. So there are certain ratios. So we have a right triangle here. If I'm standing at this angle, then this one is opposite, this one is adjacent, and this one is the hypotenuse. Okay? Those are the abbreviations for opposite, adjacent, and hypotenuse. Now, when we're talking about, say, this 60-degree angle, okay, the ratio of the opposite to the hypotenuse is what we call sine. Opposite over hypotenuse. Sine is opposite over hypotenuse, the ratio of the long leg of this triangle to the hypotenuse, the ratio of the side across from the angle to the hypotenuse, the side that we call the hypotenuse. Cosine is the ratio of the adjacent side to the hypotenuse, the adjacent side to the hypotenuse. And then tangent is the ratio of the opposite to the adjacent, or opposite over adjacent. Now you have to memorize these ratios. And there are a couple of tricks for doing it. I just remember sine, cosine, tangent. Sine, cosine, tangent. I memorize that. Then I say opposite, adjacent, hypotenuse under the first two. Opposite, adjacent, hypotenuse under the first two. Now, another way, SOH, CAH, TOA. I could never remember how to spell SOHCAHTOA, so I never used it. So, I'm spelling it wrong already. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you have to decide how you want to memorize these, but you have to memorize these. You have to know this. Say it again.
I pretty much know how to spell SOHCAHTOA from like 2 years back when I memorized it.
Yeah. SOHCAHTOA. Okay, so now we use these. All of this information is programmed into your calculator. That's what a scientific calculator is. It has these programmed into it. And you'll see sine and cosine, and I believe you have a tangent button also.
I was always wondering what this did.
Mm-hmm. Yeah. So now, when we have if you remember from special triangles, when you have a 60-30 triangle, when this is 2, this is 4. This is 2 times the square root of 3, isn't it? But let's not worry about that right now. If you remember from special triangles in geometry, when the short leg is 2, the hypotenuse is 4. If the short leg is 5, the hypotenuse is double that of 10. If the hypotenuse is 15, if the short leg is 15, the hypotenuse is 30, right? That is a 0.5 ratio, 1-to-2 ratio, isn't it? A 1-to-2, a 1-to-2 ratio. One of these is 2 of these, right? Does that make sense, Maddie? It's always like that for a 60-degree angle. Always. Okay, so now suppose I don't know this one. Okay, suppose I don't know this one. This is x. Now, if I remember my special triangles, I just double that, right? But I can use the trig ratios because the sine of a 60-degree angle I know is 1-to-2. Your calculator knows that it's 0.5, 1-to-2. right? So then sine of 60 degrees, if this one is 15, and I know it's 1 to 2, then I know this one has to be 30, right?
Mhm.
But now let's use our calculators to do this. We know that sine of 60 degrees, sine of this angle right here, I'm sorry, I'm using the sine. This is cosine. Messed that up. Adjacent over hypotenuse, adjacent over hypotenuse, adjacent over hypotenuse, right? This is cosine. Cosine is 0.5. So you see, I was thinking about this one to this one, but it's adjacent, the adjacent side to the hypotenuse. Do you see that? I was just throwing out sine there without thinking. So I know that cosine of this angle is always going to be whatever this is over whatever this is, right? This over whatever this is, right?
Mm-hmm.
Okay, so now I need to get x alone. Now, take a look at this. 10 over 2 equals 5, doesn't it? 10 divided by 2 equals 5. Or, let me put it like this. 5 equals 10 divided by 2, doesn't it? Right? We know that to be true, right? But look, if I switch these two, 10 divided by 5 equals 2, doesn't it? You see that? We know that's always true. Because that's from the fact family, isn't it? 10 divided by 5 is 2, and 10 divided by 2 is 5. So I know that these two are interchangeable when I'm solving an equation, right? You tuned in? That's the shortcut. But let's take a look at how we would get x alone here. Just think of this as one whole thing. Well, the first thing that we would do is we would multiply both sides by x to get rid of our fraction, wouldn't we? X times the cosine of 60 degrees equals 15. Is everybody with me?
Mm-hmm.
And then we would divide, to get x alone, we would divide both sides by cosine of 60 degrees, right? This would cancel this out, giving me x equals 15 over cosine of 60 degrees. Does that make sense?
Mm-hmm.
I've solved for x. I've gotten x alone. Now look, the shortcut was, I hear some noise in there. I started out with cosine of 60 equals 15 over x. I end up with x equals 15 over cosine of 60. You see, I just switched these two, didn't I?
Mm-hmm.
That's the shortcut because these are interchangeable. So we don't have to go through all of this. When our variable is down here, we know that we can just switch these to get x alone, right? Now, your calculator, so I'm looking for the measure of this side. Your calculator has in it what cosine of 60 is. It has it programmed in it. So in your calculator, put 15 divided by cosine of 60.
Right, yeah.
She's studying instead of talking.
0.5. No, 30.
What did you get?
30.
30. And we know that's true, don't we?
Mm-hmm.
Because we know when we have a 30, 60, 90 triangle, whatever our short leg is, this one is double, huh?
Mm-hmm.
That's programmed into your calculator. Now, what if this were a 50-degree angle? Then what is the length of this hypotenuse? Well, we don't know that now because it's not a 30, 60, 90 triangle, but we can figure it out.
Mm-hmm.
We see we have, from this angle, this is the adjacent side, this is the hypotenuse.
Mm-hmm.
I have the angle, I have adjacent, and I want to know hypotenuse. I have adjacent, and I want to know hypotenuse.
Right.
So that's how I know to use cosine. You see that, Miss Maddie? I have adjacent, and I want hypotenuse, so that's how I know to use this ratio. So now I'm going to say cosine, because I have adjacent and I want hypotenuse. I have my angle, 50 degrees equals 15 over x. Now, I know that when my x is here, I just change these out. X equals 15 divided by cosine of 50 degrees. So now, what is the length of x? If this is a 50-degree angle. What'd you get, Maddie?
23.33585.
Round it out to the nearest whole number.
23 point.
The nearest whole number. Not the nearest tenth, the nearest 23, huh? Did you get that?
I got 3/10.
Did you do 15 divided by cosine of 50?
Mm-hmm.
Did you close the parentheses?
You don't have to for cosine of 50.
Oh, never mind. Now I got 23.
Very good. So that means the length of this side is 23. Now when this was a 60-degree angle, look right here. When this was a 60-degree angle, this was tilted up more, and so this was longer, wasn't it? But when I bring this in down to a 50-degree angle, close this up a little bit, then this side gets shorter, doesn't it? Okay? Now, what if this were a 40-degree angle? Then what would the length of this side be?
Rounded it to 20.
So 20. So it's even a little bit shorter than 23. As I bring this angle in more,
Wait,
it gets shorter, doesn't it? Did you get 20?
I got 21.
Do 15 divided by cosine of 40.
21. That's such a close number to
I
have.
know, it's very close. I know.
What'd you get?
I keep getting different things.
Okay, so put it down, and let me watch you. Go ahead.
Divided by
Wait. Okay.
40. Okay, I see.
No, that's, oh, I see what you're doing.
Yeah, I see.
Do it again now.
Put it down. Put it down.
Slow down.
Divided by 40 cosine.
Max.
Okay,
Down
do
now.
this. Clear it. 15 divided by cosine.
Way to participate.
That's an old image. So you have to do it by cosine.
Yeah.
Okay, so
Only way you can get through it.
so now, what if I had a 40-degree angle, and this is 12, and I want to know these two sides. Let's first of all deal with x. I have my angle.
You would use sine.
I have my opposite. I know you know because this is the third time I've taught you, so hold on now. I have my angle. I know I have my opposite side and I want my hypotenuse. I have my opposite and I want hypotenuse, so yes, I'm going to use sine. Very good. I'm glad you remembered that. So I'm going to say sine of a 40-degree angle, the ratio of a 40-degree angle, when we're talking about opposite over hypotenuse, is 12 over x equals 12 over x. So now, what is the length of that hypotenuse?
19.
Make sure everybody gets 19.
Oh, wait, no one.
You gotta change the voice. Always.
19.
Oh my god, stop.
You gotta change the voice.
Stop it.
That's not an average.
What'd you guys get?
Stop it.
19.
19, okay.
Mr. Bowen, you take them a little break? Is he supposed to be practicing his lines?
He's an actor.
Weird.
Go, let's put it away.
He's an actress.
Put everything away and let's do some more math now.
Mr. Boone, if you can't stick with that math, let's put it away. If you can't stick with the math, I'm gonna have to bring you in here by me, okay? Okay, just a little bit more. Okay, so now, what did you get? Did you get 19, Matthew?
Yeah.
Very good, very good. So, now how do I find out y? Now this is approximately 19. Trig ratios are ballpark. They're approximated because they're usually approximate because they're radical numbers, and so we're going to get rounded to the nearest fourth digit usually, I think. But anyway. Okay, so now how am I going to figure out y? Now look right here. From this angle, I have opposite and I want adjacent. Opposite over adjacent. So I put tangent of 40 degrees equals opposite over adjacent 12 over y. Instead of sine over 40, I'm going to use tangent over 40 because I want the adjacent side, right? What'd you get? 14. Did everybody get 14?
Quick picture.
Oops. Y'all have that written down,
I
right?
took the picture.
Very good. Now,
Anybody need this?
Keep going. Yeah.
No? Oh, yeah. Yeah, you need it.
Too late.
It's gone now.
suppose I give you a triangle. I tell you that this is a wet board.
Why would you tell us
I
that?
know, huh? Thought I hadn't wiped it over here. Okay, so here we have a right triangle. I'm going to tell you that this is a 38-degree angle. This is 14. What is this? Now, you have hypotenuse and you want adjacent.
Right triangle.
Yes, always right triangle. Yes, thank you. This is only with right triangles, only with the 90-degree angle here. So what ratio, sine, cosine, or tangent, Matthew? Which one am I going to use?
You want well, you would want a
I have hypotenuse and I want adjacent.
cosine,
Cosine.
cosine.
Cosine. That's right. Cosine of 38 degrees equals adjacent over hypotenuse. Adjacent over hypotenuse. Now you see my variables in the different place, isn't it? Now it's in the numerator. How do I solve this? How do I get x alone?
How do you know if it's in the numerator?
Well, adjacent over hypotenuse, you see?
Oh, okay.
Adjacent over hypotenuse.
Oh, it has to be like that. Okay.
You see that?
Yeah,
Do you divide cosine by 14?
probably.
No. Oh, no, no. No, you can't just
Multiply.
divide the other side by 14 instead of this side by 14. But look, how do you get rid of it? You multiply both sides by 14, right? Because this cancels this out, leaving me with x alone, and you have 14 times cosine of 38 degrees. So now punch that into your calculator. What is 14 times cosine of 38?
11. Wait, yeah, 11.
Yeah.
Wait.
So we know when this is a 38-degree angle, this side, and this is 14, then this is 11. So when my of any degree equals 5 over x, when my variable is here, I switch these two, don't I? And I get x equals 5 over, say, cosine of 27 degrees, right?
Mm-hmm.
When my variable's in my denominator, I switch. The shortcut is I switch these two. When I have, say, cosine of 38 degrees equals x over 14, then I multiply both sides, so it's 14 cosine 38 degrees equals x, right? So when the x is in the numerator, I just multiply both sides by the denominator. Now, let's take a look at this triangle. And suppose I tell you, let's use these, 14 and 11. If this is 14 and this is a length of 11, what is the measure of this angle? Well, we know it's 38 degrees, don't we? But how can we get our calculator to tell us that? We have adjacent and hypotenuse, right? So we say cosine, we could say cosine of x, but very often, instead of x, you'll just see this theta sign. It's just a variable just like x. But when you talk about an angle measure in degrees, often you'll see, sometimes you'll see x, but very often you'll see theta. So cosine of this angle, it's unknown, isn't it? But we know that cosine is adjacent over hypotenuse. 11 over 14, right?
Mhm.
Now, this is how you do it in your calculator. You see how to do it when your variable's here, Now your variable is here instead. So, you switch just these two, and you add a -1 up here, it means inverse. Cosine inverse or inverse cosine of 11 over 14 equals theta. How do you find inverse cosine? Second cosine. Instead of just cosine, your second cosine or your shift cosine button. Press the shift button and then your cosine button. And that gives you inverse cosine. So you're going to press second cosine or shift cosine. Put in parentheses 11 divided by 14.
38.
And you get 38. Did you get 38, Miss Maddie?
Yeah, makes sense.
Lucas, can you make sure she's pressing the right buttons?
Unless she typed in 38, I would use that.
Hold on, y'all. I'll have to go in.
At
Hit the printer button here.
Famous Dexter's 08.
Did you get 38, Maddie? So now,
Water.
what? Say it again. Did you get it?
No, I did not. I
Oh.
figured out how to do it.
I'm sorry. In second cosine.
I
So,
know second cosine, but I mean like.
Who's your favorite
so you're gonna say
Who's your favorite
second cosine.
Who's your favorite
I thought you hit your head.
No.
Calm down.
So you're gonna have to put your number in first. 11 divided by 14. Second cosine.
Oh, okay.
You see it?
Yeah.
Because you've got a different calculator.
Where we going?
Now, so figure out what the measure of this angle is if this is 10 and this is 2. Figure that out with a hypotenuse of 10.
Negative. $78.
Wait, did you do 2 divided by 10?
But you have to do negative cosine.
Yeah.
What do you do? Actually, that's 2. Yeah, what? You did. What's the Migos and they say something.
Not really. I would look at any of their songs now.
I feel like they do.
They always do stuff with people who do.
And then designers ad libs. Those are hard to say.
Oh my god.
He says you dig a lot, but them sounds he makes. Yeah. 78.
Okay.
The most rap sounds that he makes. I don't know.
Yeah.
I wish I could make those.
You probably.
Oh yeah, you hit me saying a lot of times.
I'm so happy I didn't go to school with designer.
You just hear it throughout the class.
99% of the ACT tests have 2 questions on these right here.
It's set up like simple like that, but just
Simple like this. Simple. That'll bring your math score up a point right there. Just really knowing this, the basics of this often will bring your math score up to 1 point. 2 questions, 1 point.
we just gotta know which one to use. Huh?
Well, yeah, you have to know sine, cosine, tangent, so the opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so what's the measure of this angle, Matthew?
78.
78?
Mm-hmm.
Very good, very good. So do these 3 now.
That part. Social media neighbors.
Oh my God, stop. Oh, you shut up. It's the problem.
Solve these 3 for me.
It's 90. That was the first.
Yeah.
Solve those 3 for me.
Opposite over adjacent. Tangent.
Yeah, there's 10. First one's 10.
Or 20 divided by.
No, it would be, oh, it's
20 divided by 24. Oh wait, it's 4 divided by 10. It's 1.
That's what I just said. That's,
Correct. Negative 20.
no, it was only the last one. This was but this time we have to multiply.
It depends on where your variable is, huh?
Right.
Times 10 times tan 32. Did I say 10?
Yeah, you said that.
Did I miss say sine? Is that what it was? Yeah, sine.
Yeah.
10 times sine 32.
10 times sine 32.
Because you multiply. I got 5.
Such a complex equation for 5.
Oh, wow.
Oh, yeah. That would be inverse, and since we have opposite and hypotenuse, it would be sine again. It would be
The negative sign.
yeah, inverse sine.
It's not negative, it's called inverse.
Right. Trying to remember which one. So we're doing sine, so inverse is
Opposite over 5. So
3
3
at
at
5
5.
would be 3 divided by 5. 37. That meme came out, it was Lil Uzi and Bad Bougie. It was just, yeah, they just kept on going.
Anybody having trouble?
No, boomerang's backwards.
Yeah, I'm pretty sure.
It's just a repeat.
I'll call that like.
Yeah, that's what it's called. Boomerang would go forward.
Yeah.
One of my friends, we found her old music player account. We were up all day. She was like 13.
I understand.
That's what they tell them.
I understand. It's like mountain song.
I mean, look at Jacob Stag, whatever.
But yeah, that just proves my point. I don't see like I think by Instagram has high points at least.
Miss Maddie, what'd you get for the first one? Listen up. 11.
Me too.
Everybody agree?
Mm-hmm.
Brandon, you agree?
I
Okay.
thought you meant number 11.
Matthew, what'd you get for the second one?
I got x equals 5.
5. Everyone agree? Brandon, what'd you get for the last one?
37.
Everyone agree?
Didn't get to that one.
Okay, but this is very fast math. It doesn't take long, right? What's holding you up?
I don't know. It's just taking me a while.
Okay, yeah.
I think I need to figure out which one it is because I don't know. So.
Okay, so let's take a look at how to do that. Right here, opposite and adjacent.
Right, that's tangent.
You see that?
Yeah, I kind of have to
Tangent.
learn it.
We know the degrees. You can look at your chart right now. And we know it's opposite over adjacent. So it's that, right?
Right.
So now we know when our variable's here, the answer is going to be 4 divided by tangent of 20. And we punch it in.
Mm-hmm.
Here, what do we have? Opposite and what?
Tangent, opposite and adjacent.
This is not
No,
adjacent.
not adjacent. Sorry.
Hypotenuse.
Hypotenuse,
Hypotenuse.
And then that's sine.
Very good. So sine of 32 equals opposite over hypotenuse. So we know we multiply both sides by 10, right?
Right.
And we punch that in. Sine again, but here, so we know it's going to be inverse sine of 3 over 5 equals theta, right?
Right.
And we punch that in. Okay, let me go see if your sheets are ready. The printer has run out of paper.
I called off real quick.
That's 36.
Come over here, man.
What? Mine come.
I was about to smack you in the face.
I see some people sleeping like that. How do you sleep like that?
I don't know. If I'm in school, I understand. Like sleeping wise.
You look like that's uncomfortable. Yeah.
Now sometimes we have a word problem. So I want you to draw a picture of what I tell you. Listen up.
Well, a lot of the times in the ACT they have a word problem, but also the picture. And at that point, just ignore the word problem. Go straight to it.
Yes, that's true. But listen to this. You are 200 yards from a river. draw a river and draw yourself 200 yards from that river. Put a dot for you. You're 200 yards from the river. So now draw lines directly from the river to you and mark it as 200. Rather than walking directly to the river, though, so you're not going to walk that 200, are you? But you need that information. Rather than walking directly to the river, you walk 400 yards along a straight path, so you're going to go straight, and you're going to get to the river's edge. So instead of walking straight to the river, you're going to walk this way, and you're going to walk 400 yards before you get to the river. Right? Does that make sense? Draw that. Now, you could have walked, look right here, you could have walked straight to the river, but you walked this way for 400 yards. What was the angle of your original path to the new path that you took? What acute angle is that?
I can figure that out. Let's see. Let's see.
Matthew, you can turn around and and work together if you want to with them.
Good.
But if you think about it, that's
This
okay
is
too.
like, this is like the same thing as that.
Exact same thing,
For a second, I was.
but it's a word problem instead, isn't it?
Yeah.
I'm giving you a lot of the answer sheets, but when I check your binders, I want to see the work. I don't want to just see the answers written down. I want to see the work. So if I pick up any of this homework, I'm going to want to see the work. But I want you to have the answers so you can double check to make sure that you're doing it correctly.
That's what I thought. That's why I wrote it.
Yeah, I know. I didn't even have to write that. I really thought they were going to do that.
That's why we have to do the inverse.
I was already calculating my first one was which, and then by the time she said, I realized that that's inverse, that she was asking for inverse.
Lucas, what did you get?
I got 60 degrees.
Say it again.
60 degrees.
60 degrees. Maddie, did you get that?
I'm a little confused.
Okay. Lucas, can you show Maddie how you got that?
Yes.
So, since we're looking for this angle.
Did you get it, Matthew?
I got 30.
Okay, turn around and see what he said.
Right.
Did you
And
get it?
so, what do we have here? We have hypotenuse and adjacent. So, since we have hypotenuse and adjacent, we can look back. Which one has it? Out of all of these, which one has both adjacent and hypotenuse? Exactly. So, now, we already know that's inverse. So, what we're going to do is hit second and inverse cosine. Now,
Did you write your equation out? You have to write it out, or I'm going to mark it as wrong, huh?
Cosine inverse
Oh,
over
we gotta write it out like that?
Oh, wait.
200.
You have to write out your equation and then solve it. Wait, Matthew, are you up to speed with where they are?
Yeah, I must have written a picture on or something.
And so how I figured out which one goes right here and right here is because if you look at this, it says adjacent over hypotenuse. So what I did was I took 200 first and then hypotenuse 400 right there. And then once you put it in your calculator, inverse, of course, you should get 60. And that's that.
But what did I choose to get? What did you do?
Cosine.
You have write out your equations to get credit for it.
I just write down inverse cosine parentheses.
You have to write your first one out first. Write out your first one first, okay? So you can just write out how much you want to, 'cause you know.
Okay, that picture thing's weird.
So, Matthew, when we talked about it, let's look at your
That's
picture.
wrong.
When we talked about it, look right here. I said
Cosine,
directly
inverse cosine,
between,
200
here's the
or
river.
equals whatever that whole
Here you are. I said a direct path to the river. You went this way to the river, slanted.
Yeah.
But if you go directly to the river, you're always perpendicular to it. You see that?
Right.
That was 200. Now, instead, you walked this way to 400. And so what is this angle right here? See that?
Yeah.
That's reaching from the grave to grab you.
Too dark.
There's like a college door.
Now, what is the distance from where you would have landed on the river to where you actually ended up on the river?
Yeah, that's right.
What is the distance from where you would have landed on the river to where you actually landed on the river? What is the distance of that?
Wow.
Now you know this is a what degree angle?
60-degree angle. Oh, no.
What was it?
60.
Yeah, so put 60 there. You figured out 60. Now, you're going to put your x right here, right?
Right.
Now, are you going to use this one? You're coming from this angle. Opposite. This is opposite over hypotenuse or adjacent. Which one?
I think it would be.
Either one. You can use either one. But neither one of those is cosine.
No. That one was just-
You could use opposite over hypotenuse, or you could use opposite over adjacent. You could
Right.
use either one. You're going to get the same answer either way because it's the same distance no matter what, right?
Right.
So Miss Maddie, let me look at your picture here. Where's your picture? So, 200 to the
One second, I'm
river,
gonna put the other one.
400 to the river. And you know that this is the 200 angle, not that one, huh?
Yeah.
You didn't know that one.
Yeah,
I
so,
knew, 'cause I had
which
this
one
there.
together?
But
200
this one's
times.
60, right?
So this
So now, you want this one, you want to use this one or this one? We'll use 200, okay? So now, you have opposite, see this is opposite, is this hypotenuse or adjacent? That's right. So what ratio does opposite and adjacent?
This is what your equation looks like? 200 times tan 60
Right, so right
equals.
tangent,
I just did it.
oh, very good, tangent of a 60-degree angle, you got it, I'm sorry, yeah, is opposite x. X over 200. Right. Now, when variables here, when unknown is here, what do you do? That's very good. Very good. 150.
I'll see. I said no.
Who's also?
I said no. He went to this school for like longer than me.
I don't know.
What'd you get, Maddie?
Yeah.
346.
Yeah.
Check yours then. Where's your error, Matthew?
I don't know. The picture keeps confusing me.
Okay, let's take a look at it.
I'm trying to figure out which direction
This
it's
is a
facing.
60.
I'm just
Facing out.
I'm making it easy. I'm making it hard over here.
Adjacent. Tangent of 60. You got this right.
Okay.
But tangent of 60 is what? Adjacent over opposite or opposite over adjacent?
It's the opposite of radiation.
Yes,
Nice.
opposite over adjacent. There's the problem. See that?
Yeah.
Except for Daniel. Daniel graduated mid-year.
Okay, guys, the first two sheets that I gave you are just answer keys. I want you to work each one of those and test yourself, make sure you get the answers, right? Then go through and complete your packet. Number your pages for me, please. What number is it going to start with? Everyone agrees 327?
Yeah.
Okay.
Yeah,
Let me put. So, how many page? What page number do we get to?
Before this packet?
No.
After.
What are we gonna do? We're gonna do that whole packet. So it's gonna be Algebra 2 is page 327 to what?
I'm doing that right now.
27 to.
I'm just put like the time.
Okay, everybody's packed up.
Can you stop saying it out loud? You get me.
36, 872.
I wouldn't be surprised if I had like 6,336 on that one.
Yeah. Oh god, I wrote 327.
Try.
Yeah.
337.
400.
Man, how many pages we got?
I already do 401.
Okay. Alright, 407.
Really? What you grab my arm?
Trying to mess you up even more.
Yes, in the closet in the corner if you can. Thank you, sir. What is it?
It's, what was it, 407?
No, you're good.
Hold up. Did I write too? No, it's 408.
488?
Did you get 408, Matthew?
Wait, for what?
For the last page?
Oh. No.
What'd you get?
Correct.
I might
We
have
got 346.
Well, that makes sense. It wouldn't be 408.
Wait, what?
Wait a minute.
How'd you go back?
Oh god.
Wait, what's the pages?
She has a 346.
Wait a minute.
Hold up.
Give me a second. Give me a second.
200 times.
Yeah.
326.
Yeah.
Wait, I'm
Oh,
sorry.
wait, I
I
jumped
just
from-
confused you.
I'm done. We jumped from.
I started.
We jumped from 339
Do you have those papers out? Look, Joe, is that your root beer can?
I'm
Pick up those
looking
cups
at
for
her
me.
right now.
Learn how to count now.
341.
Alright, so I gotta renumber all these.
I'm just renumbering the last one and just gonna. So I'm not looking like, oh my god, where is it?